We are talking about radical functions today, and just a reminder, a function must pass the vertical line test. It can only have a single x to, or a single y to each x. Okay, it has to be able to pass the vertical line test. I just want to remind you of that before we start talking about more functions. So the type of functions we're addressing now are radical functions. Now, these are equations that have a variable under the radical symbol. Now, a radical symbol, you guys typically call a square root sign. It technically is not a square root sign, it is a radical symbol. It becomes a square root sign when we know in the context we're trying to take the square root of something. Now here are some examples of radical functions. Okay, we've got y equals the square root of x. Okay, we have a variable under the square root sign. Now anytime we see that radical symbol in an equation and there is no number there, we are going to call it a square root sign. Here we have a square root or a radical function, y equals 3 times the square root of 7x. There's an x under the radical sign. Now here, if you notice, we've got a number right here. This is called an index. That's going to become important as we're working with radical functions. This equation is y equals the cubed root of x. And here, if you notice, we have an index of 5. This equation is y equals the fifth root of x minus 4. Now, let's very quickly look at one example that is not a radical function. Y equals x square root of 4. Let's say 41. There is a radical sign here, but there is not a variable under the square root sign. So this is not a radical function. Okay? Now, being able to change that index means that there are different types of radical functions. Okay? And today we're going to introduce the square root function, which means we're going to have a square root symbol in them, and we're going to introduce the cube root function, which means we are going to have an index of 3. Now, often in math, you guys know, we have understood ones in front of exponent or variables. We might have an understood 1 as an exponent if I write an x. We have an understood 2 right there. You can write it, you don't have to write it. But if it's not written, we're going to assume it in an equation. All right, so the square root parent function is y equals, let's do f of x. F of x equals the square root of x. Here's a picture of it. Oops, that's not a picture. Here is a picture of it. Okay. Notice that it's starting where the x's are positive. There aren't any negative ones. Why? Because remember, if we put a negative underneath a square root sign, we are going to get an imaginary number. And we're not dealing with imaginary numbers right now. We're working in the real number system. So the square root function is what we call the inverse of the quadratic function. Because let's think about it. How do you undo x squared? You take the square root of it. And they cancel each other out. Okay? So we call this the inverse function. Now, because, and I'm going to draw on my graph over here, because the quadratic function has two sides to it. It has the negative side and the positive side. Notice the square root function only has a top. It doesn't have a bottom. Well, let's think about this. If it had the bottom, would it be a function anymore? No. So you might hear some weird language along the way about the square root function being the inverse of a quadratic function, when we restrict the domain, that's why it's saying that. So we're not ever going to deal with this bottom part of our square root function because it will no longer be a function. Okay? Okay, one last thing I want to point out. Notice we don't have a vertex. There's not a point where it's changing direction. We are going to call this point here at the end an inflection point. That is going to be a point that we're going to use when we're graphing and doing transformations, just like we would use the vertex. You know, a lot of times we would move the vertex first and then move everything else. This inflection point is a point that we're going to use to do that. Okay, the next function that we're learning today is the cube root function. This is a function that has a variable under a radical symbol that has an index of 3. Okay, so my parent function is f of x equals the cube root of x, and here is the graph of it. Now, this is kind of a weird looking graph, but I do want you to remember that we had x cubed looked like this, didn't it? Okay, so the cubed root of x is, again, what we would call the inverse of x cubed. Okay, so you will hear things about that as you go on in math. Now, also, we have an inflection point on a cube root function. An inflection point. Again, we do not have a vertex. Though this is making a change right here, it is not actually changing directions. We're still increasing. But this point right there is the point that we'll use like we do the vertex on a parabola. We will be able to move that point or refer to that point to move and refer to other points. So these are the very basic things that you need to know. You need to know your parent functions, you need to know what they are inverses of, and you need to know where their inflection points are. In class, we are going to visit the key characteristics of both of these functions, something you've done all year long, and that's all we have today.